So this is the question, count the largest group. Okay, so here you given a number, an integer n question, like n is an integer, it's given, then each number 1 to n, the number is itself 13, then it starts from 1 to 13. Okay, then return the group of number that have the largest size. Okay, it have to be written the largest size, which is 4. Okay, so here is the example number. We take the number n equal to 13, and there's group from 9 groups. There are 9 groups, and a group according to the sum of the digits. Okay, group are based on, so group based on sum of its digits. Group based on sum of its digits. So the grouping what we are doing is totally based, depends upon the sum of digits. Okay, initially we starting from the brute force approach, that was we are starting, that is from the initial number, like we have to start the loop from 1 to 13. So initially it's 1 2 3 4 5 6 7 8 9 10 11 12 and 13. Well, now we get 13 number of groups, but here in question it's totally, it's declared that it has 9 number of groups. Okay, so we have to be find out how will we get the 9 number of groups, like from 5 to 13. Okay, here the groups is number of 1 to n according to the sum. Then here it's sum of digits is 0, sorry, sum of digits is 1, it's 2, it's 3, it's 4, so on. Here it's 9, it's 1 plus 0 equal to 1, 1 plus 1 equal to 2, so 1 plus 2 equal to 3, and 1 plus 3 equal to 4. So here we get 1 2 3 4 sum of the digits. So here it question is in explanation section, it's saying that we have to arrange all the numbers according to sum of the digits. So it's easy to be arranged right now. So we will be arranged from 1, right? So we're starting from 1 0, then it's 1, then 1 1, it's 2, then 1 2, then it's 3, then 1 4, and then it's 3, 1 2, then 1 3, it's 4, then so on, 5 6 7 8 9. So this is 1 2 3 4 5 6 and this is the 9 groups now. 9 groups now. What is the question? Between 9 groups we have to be return largest size. What is size? This is the size, like 1, this is the size of 1, this is 10, this is the size of length 2, this is of size of length 2. So we have to be calculate the highest size, highest possible size. Okay, so how we will get the highest possible size? Like we are starting from the 1 to 13. Okay, we have to be calculate the length of this number, and length plus as well as the sum of the digits, sum of the digits also. So here how to be calculate the sum of the, first we have to be see the sum of the digits code. Okay, now it's time for the logic building, how to solve. Case 1, first we have to be calculate let the digit sum. Okay, then case 2, check the length of the digit. Then case 3, return the highest group. Okay, these are the 3 use cases. So if we find, then we go to the write the code section. Okay, what is the logic? To calculate the sum of the digit, we will write a method, that is public static find digit and n. Okay, here it's a pseudocode. Okay, int sum equal to 0, we initialize sum as 0, while n greater than 0, then sum loss equal to num modulo 10, then n divided as itself equal to 10. Equal to 10. Okay, now we return sum here. Now we find the sum right now. Now get the main process, like where we match the length of itself, the number, its highest length. Okay, how will you get the highest length? Okay, so for that we write another method, public int count largest group. Okay, int n. Here we take an array of size 37, because if we took a larger size of array, like example 9 plus 9 plus 9 plus 9, 4 times 9, if the number is look like this, it's the highest number. So after sum of this number, it will be coming out 36. We took one more space, 37. Okay, then take int max size equal to 0, because we have to be calculate the size, right? Then we take one more variable, which is count equal to 0. Okay, now count equal to 0. This is, now we start a loop. Okay, loop is starting from 4 int I equal to, in question it's given that I should be starting from the 1. Okay, int I equal to 1, then I less than equal to n, then I plus plus. We start the loop from the I, like 1 to 13 itself also. Okay, then we will calculate the sum of the digit. Then we take one more variable, int sum of digit equal to, we call this method find digit, pass the value I. Okay, we will be dry on it later. First complete the code. Okay, then ARR sum, then sum of digit plus plus. Let's dry run it. What will happen? Okay, we will check while up to this we will be take a dry run. Okay, initially our number is 1 while I equal to 1. Okay, it pass into here, then calculate the sum and return. It's return first 1, sum equal to 1 initially. Then we store into an array. In array we'll store it. Initially all values are 0, default value of array. Okay. Then when it's 1, 2, 3, 4, 5, 6, 7, 8. Okay. While it's 1, I equal to 1, then it will be update its index. Update index means sum of digits plus it's 1. Okay. Then index plus plus, then it's converted in one place to 1. Okay, because we are plus or adding, we converting this 0 to 1 in 1th index. Okay, while it's I equal to 2, then it's changing it into 1 and second index, update the value. Then I equal to 3, it's again update the value into 1. So we will take a larger size array. Okay, it's a small, took the 13 number. 0, 1, 2, 3, 4, 5, 6, 9, 10. 0, 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. Yes. 0, 0, 0, 0, 0, 0. Initially its all values are 0. Okay, now its value is I, it's converted to 1. Sorry, it's converted into 1. Then because we are right there ARR, sum of digit plus plus. Okay, so it's now it's ARR of 1 plus plus means update the value itself in 1. While it's 2, let's update the value into 2. While I equal to 3, let's update the value into 1. Sorry, let's update the value into 1. Okay, in I equal to 4, it update the value itself is 1 in 4th index. Okay, so on, it's changed into 1, 1, 1, 1 here in the 9th index. Okay, while I in the 9th index, it actual value equal to I equal to 10. 10 in 10, it will be returned 1 plus 0 equal to 1. Okay, now it's while I equal to 10, its actual value equal to error 1 because it's returned the sum 1. Then plus plus, while it's 1 in ARR of index 1, in error of index 1, it update the value into 2 because here it is plus plus na, so it update the value 1 to 2. Then while I equal to 11, mean 1 plus 1 equal to 2, it's written 2. Then ARR 2 plus plus, then it update the value into 2. Then it's update the value into 2, and then also it's update the value into 2. Now we have these 4 2 index, we have to be return this. Okay, for the now up to this it's clear. Then we write the next part of the code, how to return this 4 element. Okay, this 4. For that we should write in code for that. Okay, so here is code for the check for that element, like adding the elements. Okay, now we are write the for the condition checking. Okay, now to check the condition we should write if ARR of sum of digit equal to max size. Initially max size equal to 0. Okay, max size is initialized as the 0. sum of digit equal to max size, then count plus plus. Okay, else if either it's equal to the max size or it's greater to the max size, then we write the code for the, because it's not been smaller. Why? Always max size is initialized as the 0, so there is no smaller element from max size like 0. Okay, sum of digit and else if sum of digit greater than max size, if it's greater in size. Okay, greater than max size because it's 1 na. Here the size is 1, initially its size is 1, then it's updated into 2, it's greater. Yeah, greater than max size, then in that condition what could we do? We reinitialize max size equal to ARR of sum of digit. Okay, then count reinitialize as 1 here. We'll be doing it in hand run. We will be running this code in the Leetcode, don't forget for that. Then return count. Okay, what happened here? Let's check. Here initially sum of the digit, like it's 1 will be checked with max digit. Is it equal to 0? No. Then is it equal to 0? No. Then what will be happen? Then it come to the this condition. What check? 1 is greater than 0. Okay, now if 1 is greater than 0, then we reinitialize like max size equal to initially it's 0, we change to 1. Okay, then count equal to, now count is also equal to 1. When it's written, like we change from this index to this index, then check for the 2. Okay, while sum of the digit is what right now it's 1 is equal to max size reinitialized as 1. Yes, it's correct, so it satisfies this condition. Now count plus plus, count changes into 2. Then again it's 1 for this position, then initially it's check 1. Yes, it's 1, the count changes into 3, so its count will be incremented up to 9. Okay, because its index position in index value we updated first it's 1, then when similar number will become, like if there is error of 2 here, its position we change the value 0 to 1. If again ARR 2 will become, then this value changes into 2, else it will be remain 1. Okay, so on. We check up to the 9. Up to 9 count will be 9, while 10 will become 10 will be right now converted into 2, because initially it's 1. Here we change the value here na, 1 to 2, then 2 is greater than 1. Now count is reinitialized as 1. Okay, sorry, well 2 is count is reinitialized as 1. Then again 3 will come for, this is for 1 0, this is for 1 1, then 2 will become, 2 will be greater than equal to 1, then count is equal to reinitialize as 2, then 2 again will become for 2 equal to here. First initially 1 is greater than, then 2 equal to it's again updated into 2 here, because here is the code na, we updated this here. Here you update the value to, it's not greater, it's equal to 2. It's for 1 2. Okay, it's for 1 2. then it's again it increment into 3, then it's time for the 1 3, then 2 equal to 2 for 1 3, then it's reinitialize into 4. Then after completing the execution of the total numbers like 1 to 13, it will be return the value 4, highest size of the group. Okay, let's recap once again. First question is saying there is an integer. Question is saying there is an integer n number which is 13 starting from the 1 to 13. This now return the number of return largest size. What is the largest size? This is 1 to 13. Okay, we run up to the 13. 13 or largest size mean we have to return the 4. We have to return here 4 for this like 2-digit number. In the highest size there is occurrence is 4, and we grouped them all into the sum of the digits. So initially there are 3 use cases come. Use case 1, calculate the digit of sum, check the longest digit. Then use case 3, return the highest group. Then what we do, publish static, we declare a method. Here we declare a sum. While n is greater than 0, we will be calculate the sum, where sum plus equal to num modulo 10. Then n divided into 10. We will be calculate the each of the digit, like sum of the digit here, sum of the digit. Then we write another method here, public int longest group. Then we calculate the new int 37. We arrange give the size in 37 because we choose like 949. Then it must be 36 in number plus 1, which should take the 37 in number. Okay, int max size 0, initialize 0, count equal to 0. Then after the count we started loop from I to 1, starting from 1 to n. Then sum of digits, call the method, pass the value, return the value, and increment the update the value of the array 0 to 1, 1 to 2. Then here we compare this into the max size, count the digit. If it fails, it's not equal to, then if it is greater, there will 2 conditions will be occur, either it is equal to or else greater. Then we calculate the max size into, then count, we initialize as the 1, then return the original value. Now we should code that. Okay, let's see. Question, here is count the largest group. Now we start coding. First, initially we declare an array. Array is int error of new int. We take 37 max digit sum for the 9 plus 9 plus 9 plus 9. Okay, equal to 36. So next, int max size equal to 0, and count equal to initialize as 0. Initially it's both of the numbers, initialize as 0, both of the variables. Then we start the for loop for int I equal to 1, because it's mentioned here each number from the 1. Then I less than equal to n, then I plus plus for the for loop. Then int sum digit equal to find digit. We should declare or should call a method digit for the I. Then ARR of sum digit Here we call another method, so to declare that, then public static and find digit and then and sum equal to 0, then while it's round up to n greater than 0 until it's 0, sum plus equal to n modulo 10 and n divided with 10 each in every time, then return sum. We return the sum here, then this sum will be added here. Okay, now we check the condition. If error of sum digit equal to find sum of the digit equal to max size, then count plus, else either it's equal to the number, else it will be greater, else if error sum of digit greater than max size, then max size equal to error of some digit, then count equal to 1, then we reinitialize count as 1, then return count. Let's check. Okay, we forgot to semicolon here, we missed the semicolon here. Now run. Okay, it's passed test cases. Now submit. Let's see. Yeah, it passes all the test cases. Now its time complexity is big of n, because here we are running n number of time. The loop is running here, the loop is running n number of time, and here we are checking again and again position. We are checking again and again position. So the total time complexity equal to big of n into position.